So for the rest of this course, we're going to be looking at inference, which is looking at a sample and comparing it to the population. And we're going to make generalizations about the population about that sample. So everything we've done so far up to this year about observations versus experiments, how to take a accurate sample, sample size, all that is going to be important because once you have that sample, now you have data about that sample. What can you do with it? Well, we take a sample because we can't study an entire population. So we look at that sample and we generalize about that sample, and then we think of generalize it to the population. So chapter 8 is looking at two things. We're going to be looking at confidence intervals and we're going to be looking at hypothesis testing. Okay, these are two ways to look at the sample and then make decisions about the population. So 8.1 is going to be looking at confidence intervals. How do you construct a confidence interval? Now, since we're doing this online, I'm not going to be so concerned about the formulas. Yes, I'm going to show you the formulas, but I'm going to be more concerned about you being able to do the calculations on your calculator and then interpret those values that you get from the calculator. Your calculator will have all the functions on it that will do the work for us. Okay, so the first thing we're going to look at is confidence intervals, and there are things about a confidence interval. The reason you do a confidence interval is to give yourself a little wiggle room. Okay, I can make the statement, I'm 95% confident that 3% of freshmen smell bad. I'm locked into that 3% then. I'm not giving myself any leeway. Either it's too low or it's too high. Okay, it's exactly 3%. What a confidence interval does, it gives me a little wiggle room above or below that value as where the true answer can be. Maybe the percent of freshmen that smell bad is a little higher, maybe it's a little lower, but I'm not locked into that 3%. So what a confidence interval does, confidence intervals give you a range that your event can fall into. There are two types of confidence intervals we're going to look at. Okay? Proportions, which is percentages, which is just saying, okay, I'm E-Town students, I'm 95% confident that 20 to 30% are doing something. Okay, we're talking about a group of the population and we're looking at that percentage. The other is the mean or average. Okay, we're looking at what is the average amount. Okay, the important thing to think about here is one is categorical data, one is quantitative data. Proportions is categorical. It's going to be yes, no questions, or do you fall into this category that we're looking at. For the mean, this is numerical, quantitative. We're going to be looking at a list of data and find the average of that, and we're going to estimate what the average would be for the entire population. So both are done very similar, just small different functions to do on the calculator. Your interpretation, your statement at the end should almost be exactly the same for both of your proportion or mean confidence intervals. Okay, so the first one we're going to look at is a confidence interval for proportion. Like I said, I'm not overly concerned about the formulas, but I do want to at least show them to you once. Okay, so here's the formula for proportions. And the important thing here is this beginning part. That p hat is our sample proportion. Okay, that's just a quick division problem to find the percentage of our sample. Now what that does, that gives us our midpoint. The plus minus here is how we get our interval. We take our midpoint and we add a margin of error and we subtract a margin of error, and that's going to give us the interval of where we think the true proportion would fall for the entire population. Okay, this back end here, critical value, that's what the CV stands for, critical value times the square root of p hat, 1 minus p hat divided by n, that is our margin of error. And we add it and subtract it, and that gives us our interval. So you're going to have a low end and a high end for your interval. And inside that interval is where we think the population is going to fall. The entire population, not just our sample. So here's the example we're going to look at. When 538 students at Elizabethtown High School were asked if they have ever been to Lancaster City or Harrisburg, 329 said no. Construct a confidence interval that is 99.7% confident about how many E-Town kids have never been to Lancaster City or Harrisburg. Okay, so this is telling us 99.7%. So we're going to be fairly confident about this interval. Okay, so what we need here is our confidence level, which is 99.7, and we need our proportion. Our proportion here is topic over total. Our total is 538. 538 total students were asked. 329 said no. So that's what we're considering our proportion here. N is 538, X is 329. Topic over total, which we've talked about before. To get to our function, you're going to go to stat, test, and we are looking for one prop z interval on your calculator. Okay, so like I said, we're not going to be doing the formula I just showed, finding p hat and the critical value. We're going to let the calculator do this work for us. Your statement's going to be very important, so I'm going to be a little more critical about what your statement says, since the calculator is going to be doing the calculations for us. So I'm going to exit out of the PowerPoint and get to my calculator so I can show you how to plug this in. Okay, so I said we are going to stat, tests, and it was one prop z interval. Now be careful. You can see right here there's one prop z test. We want to make sure we go all the way down to the one prop z interval. So in my calculator, it's down to A. Might be 0 or B in yours. There's a couple different variations depending on which calculator you have, but make sure it's one prop z int for interval. I want to select that. And we need to tell it our information. We have our X, our N, and our C level is the confidence level. So I said our X was 329. Our total was 538. And the confidence level was 99.7%. You want to plug this in as a decimal. So 0.997. Go down to calculate. And here's our interval. 0.54916 to 0.67389. It also tells us our p hat, which is the midpoint. This was the middle of our interval, and then the confidence or the margin of error gets added and subtracted to get our total interval. Also gives us our total again, 538. So that interval there is what we're going to use for our conclusion. Okay, that is a proportion. So we will turn that into percentages. So I'm going to go back to my PowerPoint. Here is our example. We did the calculation. Now you're going to be asked to either interpret or just explain what the interval tells us. So you're going to write something called a confidence statement. Everyone's confidence statement should almost be exactly the same. This is not creative writing. This is getting to the point and telling me the important parts of our study. So we're saying from our sample, I'm 99.7% confident that the true proportion of E-Town students who have not been to Lancaster or Harrisburg is between 54.9 and 67.5%. So it's telling us three important things. It's telling us our confidence level, 99.7%. It's telling us it's a proportion. Okay, I'm 99.7% confident that the true proportion of E-Town students, okay? E-Town students who have not been to Lancaster or Harrisburg, so it's talking about the variable. And last, it's actually giving me the interval, 54.9 to 67.5%. Now, I turned them into percentages. You can do that if you want. It's not necessary, but I just think it sounds a little nicer when you write out your statement. So again, this should be your template for all your confidence statements. Okay, no one should be varying too far off this template. Everyone's answer should be exactly the same, even though it is kind of considered a free response question. Everyone's answer should be extremely similar to each other. The way you explain the variable might be slightly different, but you should have E-Town students who have not been to Lancaster or Harrisburg, E-Town students who said they never been to Lancaster or Harrisburg, something along those lines. Okay, so that's how you would run the confidence interval for a proportion. Now for the mean, an average. So this is going to be for a list of numbers, a quantitative data set. So we have, again, our average for the sample is going to be our midpoint. And we're going to add and subtract our margin of error. Critical value times the standard deviation divided by the square root of n. That's what we're going to add and subtract from our estimate. That's going to give us the interval. Here's our example. Below is the average cost for t-shirts in the top clothing stores. Make a confidence interval that is 95% confident. So this time, it's giving us a list of data. Okay, so there's two ways to do a interval for a mean. Both of them are going to be under stat, test, and this time it's going to be t interval. Okay, so that's what I mean. Slightly different. It's going to be t interval instead of one prop z interval. So I'm going to go to my calculator. First thing you need to do, since it gave us a list of data, you need to make sure your data set is plugged in there. So there we have L3, and there's our data set. I'm going to quit out of there. Now make sure whatever, I have mine in L3, make sure you're paying attention if it's L1, L2. Okay. Stat, test, and I'm going to get down to number 8 is my T interval. T, and again, there's Z interval, there's T interval. Make sure we're in T interval. And now I'm going to have data highlighted. If you highlight stats, it asks for summary statistics, which will be our next example. But here we're going to have data. Make sure you tell it the correct list. I have mine as L3 already. Frequency is 1, so make sure you just leave it as 1 or have it be blank, but don't have anything other than 1 or blank in there. Now the confidence level this time, we were looking for 95%, so I'm going to change this to 95%, 0.95, and calculate. And just like before, it gives us some information. It tells us our average, our standard deviation, and our N, which we're not going to be using too much of. The important part is our interval. 9.7195, 16.932. That's the interval for the average cost for a t-shirt. So if I go back to my problem here, your statement, very similar to what it was before. Make sure you have your confidence level, the variable, you're telling me it's an average or a mean, and the interval itself. I'm 95% confident that the true average price for a t-shirt in the top clothing stores is between $9.72 and $16.93. And I round the 2 decimal places because we're talking about money. But the important thing is we have confidence level. I'm telling you it's the average. The variable is that it's the price, average price for t-shirts in a store. And we have our interval, $9.72, $16.93. Again, everyone's statement should be almost exactly the same. Now this next example, slightly different because I'm not giving you a list of data. 7 fossils were found of a miniature horse species. The summary data for this sample of 7 fossils is as follows. The average is 46.143 centimeters. With a standard deviation of 1.190 centimeters. A normal horse's height is normally distributed, so we can assume these heights are as well. Use this information to construct a 99% confidence interval. Now that talk about normal distribution, that's one of the conditions that, again, I'm not going to be overly concerned about because we're not in the classroom setting. So I'm really going over the most general basics for confidence intervals. So again, we're talking about an average. So the information you need is the average, the standard deviation, sample size, it says 7 fossils, and our confidence level, 99%. Okay? This is going to the same spot, stat, test, T interval again. So I'm going to go back to my calculator. Now this time, when I go to stat, test, number 8, it's the T interval. This time I want to highlight stats. So now it's asking me for those pieces. It's asking me for the average, asking me for the standard deviation. So I'll move this over a little bit just so I can see my values. Okay, so we had our average being 46.143. We have 1.19 for a standard deviation. N is 7, and I wanted a 99% confidence interval. So there's the pieces we need. We needed our average, standard deviation, N, and our confidence level. If I go down to calculate, 44.475, 47.811, there's our interval. It gives us the same average and standard deviation which we plugged in before. Sample size. The important piece is our interval here. So if I go back, the statement should read extremely similar to last time. I'm 99% confident that the true average height of a miniature horse is between 44.475 and 47.811 centimeters. So there is our confidence interval for that. Okay, so those are the ways you're going to calculate your confidence interval. Probably one of the most difficult part, though, of this chapter is deciding what type of interval. Is it a proportion or is it mean? Okay, so you really need to think about what pieces of information are they giving you. So it's important when you're reading the problem, highlight some things. Okay, highlight the information they give you, and that's going to tell you which function you're going to use, because it's asking for different pieces. A proportion problem and a mean problem is asking for two different pieces. Proportion's asking for n and your x. A mean is asking for your average and your standard deviation. So if you're looking at a problem, taking vacation can be a good time. For some reason, the ride home always seems tougher than the ride to the vacation spot. For this reason, people seem to drive faster on the way back. 520 people who were ticketed for speeding while on vacation were surveyed, and if they got the ticket on the way to or from their vacation. 403 said it was on their way home. Construct a confidence interval that is 95% confident about the number of people pulled over for speeding on their way home from vacation. So it's important to look at the information they give us. Yes, it gives us our confidence level of 95%, but it's also giving us 520 people total, and 403 people said they were on their way home. So right there, it's telling us we have a total, we have a topic, we have our n and our x. And so that means we're going to be looking at a proportion, which is 1 prop z interval. John is very conscious about the amount of water he drinks each day. Over the last 100 days, he has recorded the amount of water he drank. The sample mean is 1.3 gallons of water each day with a standard deviation of 0.2 gallons. Being 95% confident, construct a confidence interval that shows John's water intake. So again, look at the information they give us. Okay, they give us, we're looking at 100 days. That's our n, mean, and standard deviation. It's giving us a mean and standard deviation. Those are the three pieces you need to run the mean test when you run to find the t interval. So you have your n equals 100, your s, which is standard deviation, is 0.2, and your mean is 1.3. So it's important you read the problem and think about the pieces that it's giving you. Okay, the confidence statements are very similar for both, and the calculator is going to do the calculations for you. You just need to know which function you're going to use. Okay, so try some of the practice problems, and let's see how you do.